Welcome to Solve Quadratic Functions by Factoring. Use this video to help you take notes. Pause the video as often as you need to, and every time you arrive at a U-try, pause the video, attempt the problem, and press play to see the solution and my work. In this section, we'll cover the following topics. Solving quadratic functions. Remember that solving linear equations, we simply solve for x. However, with quadratic functions, we're not able to get x alone by simply moving all the constants out of the way. We can't combine like terms, so we need another method. When we solve quadratic functions, we're looking for the x-intercepts. The x-intercepts are when y is 0. So first we'll set each equation equal to 0, and then we'll do one of the following. Three things can happen when you're solving quadratics. You can end up with 2 zeros, 1 0, or no real zeros. On a graph, 2 zeros looks like this, 1 0 is your vertex, and no real zeros means it never is going to cross the x-axis. So we'll start solving quadratics by just factoring out the GCF. So let's think about factoring and distributing. These two are reverse operations. We're used to distributing to get the answer, but sometimes we have to reverse and factor it so it looks like a distributing problem. The zero product property is when two things are multiplied and the result is 0, one of those things has to be 0. Let's think about that for a second. If I told you blank times 7 equals 0, you would say, well, that has to be 0. If I was to tell you 0 times blank equals 0, you could literally say anything. So one of those numbers has to be 0. We're going to use that zero product property to help us with factoring. If we know that this times this equals 0, then either x equals 0 or x plus 3 equals 0, and then we can solve from there. So to solve quadratics by factoring out the GCF, we're going to start by setting it equal to 0, factor out the GCF, and then solve each factor. So we're going to solve each quadratic equation by factoring, and we're going to sketch the graph in these examples. So for letter A, it's already set equal to 0. So we look and say, okay, what do they have in common? Well, they have an x in common. So if I was to take out an x in this first term, I would be left with an x. We bring down the symbol. If I was to take out an x in this term, I'd be left with 3. We're going to set each factor equal to 0, so x is equal to 0 or x minus 3 is equal to 0. Well, that's solved, but we have to add 3 on both sides. X is equal to 3. We'll just sketch a quick graph. That means that it hits at 0 and 1, 2, 3. We know that it's positive, so it's going to look something like that. Let's try the next one. We need to set the equation equal to 0. I'm going to show you another way to think about factoring here. So x squared can be rewritten as x times x plus 5 times x. And they have that x in common. So I'm going to factor out the x, and what remains is the x plus 5. We're going to set that equal to 0, so each factor gets set equal to 0. X equals 0, and x plus 5 equals 0. So that's done. We're going to subtract 5 on both sides. X is equal to negative 5. We can draw a graph for that too. That would be 0, 1, 2, 3, 4, 5. We do know that it's going up, so it'll be something like this. Let's take a look at this one. Now maybe you can go in your head, I know that I can factor out a 2 and an x. I'll just show you another way. So we'll factor into primes. That's 2 times x minus 2 times 3 times x. And they have a 2 in common, an x, and a 2 and an x. So I'll take out the 2, take out that x, and I'm left with 2x minus 3 equals 0. So 2x equals 0, or 2x minus 3 equals 0. Divide both sides by 2. X is equal to 0. We'll add 3 on both sides. 2x is equal to 3. Divide both sides by 2. X is equal to 3 over 2. Give these a shot. You do not need to sketch the graph. How'd you do? We're going to move on to solving quadratics by factoring trinomials with the leading coefficient of 1. Just a reminder that the zero product property works for any multiplication. So it could be if you're multiplying two binomials together, you would just set each factor equal to 0 as well. Now, when we multiply, when we distribute, let's go ahead and distribute this for a moment. So that's going to give us x to the second power plus 3x. It's going to give us plus 1x plus 3. So what do we notice here? Okay, well, these add together to give us 4x plus 3x squared. So let's take a minute here. So these two numbers multiplied to give us to 3, and then we added them together to get to 4. And that's exactly how we factor. We're going to do the reverse. But before we do that, we're just going to quickly review some vocabulary. A monomial is one term. A binomial is two terms separated by a plus or minus. You can think of a bicycle, 2 wheels. And a trinomial is 3 terms separated by a plus and minus. Think of a tricycle has 3 wheels. Let's review some distributing. So we've got 3x times x plus 3x times negative 7. That's 3x to the second power minus 21x. And now let's think about this for a second. Remember that these two numbers are going to add together to get our middle number and multiply to get our last number. Let's see if it works. So we get x squared plus 4x plus 2x plus 8. So we get x squared plus 6x plus 8. So let's double check. To get to 8, we would multiply 2 times 4. And to get to 6, we would add 2 plus 4. So that's exactly how that works. So when we're factoring and the leading coefficient is 1, it will factor to x plus something, x plus something. And how we can figure these out is these two numbers will add to the middle number and multiply to the last number. So how do I know when I can do this trick? It needs to be a trinomial. The leading coefficient needs to be 1 or factor to be 1. We'll deal with that in a minute. And the factors of the last term, the factors, so it multiplies to the last term, need to add to the middle term. So we're going to set the equations equal to 0, factor, and then solve each factor. Solve the quadratic function. So 0 equals, now we want to know factors of the last, so factors of 7 that add to the middle, 8. So what multiplies to 7? Well, there's 1 times 7 or negative 1 times negative 7. Which of these adds to the middle? 1 plus 7. So this factors to x plus 1, x plus 7. And then we'll solve each factor equal to 0. X plus 1 equals 0. X plus 1 equals 7. Sorry, x plus 7 equals 0. And we'll subtract 1 on both sides. X equals negative 1. X equals negative 7. Let's just pause here. These are the solutions, or the zeros. How do they relate to the factors? Well, we had a positive 1, but the 0 was negative 1. We had a positive 7. The 0 was negative 7. We'll do 3 more together. So we want factors of the last that add to the middle. So we've got 0 equals, we know it's going to factor into something like this, factors of the last that add to the middle, negative 11. So we've got 1 times 10 and 2 times 5. There is no way that positives are ever going to add to a negative. So there's another way we could multiply both the numbers, because 2 negatives make a positive. And these add to negative 11. So we get minus 1 and minus 10. And to find the 0, it's just the opposite of the factor. Okay, so let's take a look here. Sorry about that. We're going to do factors of the last that add to the middle. So the last number is negative 90. And the middle number, let's take a look here, that's going to be a 1. So we know that's going to factor to x and x. Now we're multiplying to negative 90, so it could be negative 1 times 90, or 1 times negative 90. 2 times negative 45, or negative 2 times 45. So this can take kind of a long time, so I'll give you guys a minute to pause the screen and see if you can find the factors that would make this work. So we're down to 10 times negative 9 and 9 times negative 10. So be careful here. 10 plus negative 9 equals 1, and negative 10 plus 9 equals negative 1. We want the positive one, so it's going to be plus 10 minus 9, and the zeros will be negative 10 and positive 9. Last one together, 0 equals, we want factors of the last number that multiply, put those ones, to that middle number. Pause and see if you can find the factors on your calculator before me. If you're having difficulty finding factors, what I type in my calculator is negative 56 divided by 1, divided by 2, divided by 3, and I keep going until I get back to an answer I already had. So we're down to negative 8 times 7 and 8 times negative 7. So be careful when you're adding these. Make sure that they actually add up to what you want, which is negative. So we've got negative 8 plus 7. Our zeros are positive 8 and negative 7. You tried these problems. Press play when you're ready to see my solutions. So what happens when we have a negative out front? Remember, it has to be a trinomial with a leading coefficient of positive 1. Well, we can factor out the negative. So that means we're going to change every sign inside of this equation. And then from here, we're going to say, well, factors of the last that add to the middle. So pause the screen and see if you can figure out the factors that would multiply to 50 but add to negative 15. We're going to get 0 equals negative 1, x minus 10, x minus 5. And the factors are going to, the zeros are going to be 10 and 5. We'll do one more. 0 equals, we've got that pesky negative 1. We're going to factor that out and change all the signs. And then we're going to see what multiplies to negative 24 but adds to positive 2. Pause the screen and see if you can figure that out. And that factors to x plus 6, x minus 4. And our zeros are x equals negative 6 and positive 4. You try these 3 problems on your own. Press play when you're ready to see the solutions. All right, and now what happens if the leading coefficient is not 1? Well, if the leading coefficient is not 1, we see if we can make it 1. I want that 2 to be a 1, so I'm going to divide every number by 2 if I can. And because I can, we've got 108 divided by 2, we've got to see, okay, I can divide everything by 2. We'll go from there. That's the factors of negative 54 that add to 3. All right, so we've got 0 equals 2, x plus 9, x minus 6. So our zeros are negative 9 and positive 6. We'll do a couple more together. Again, we want this to be 1. Let's see, can we divide each of these coefficients by 5? We can. So we get x squared plus 4x plus 4. And we want to know, are there factors of 4 that add to 4? Pause and see if you can figure it out first. 0 equals 5, x plus 2, x plus 2. Our zeros are x equals negative 2. We don't need to write it twice. Last one together. 0 equals, can we divide each of these numbers by that leading coefficient? We can. We get x squared minus x minus 2. So we're factors of negative 2 that add to negative 1. Let's see what we get. X minus 2, x plus 1. Our solutions are x equals 2 and negative 1. You try these 4 problems. Press play when you're ready to see the solutions. Nice job. The last 2 examples, we're just going to decide if we can factor or graph. So which method would we use to solve this quadratic? We know how to factor or graph only. Well, I can factor if I can divide each of these numbers by 2. Can I divide each of those numbers by 2? I cannot, so I would have to graph. And the last one here, would we be able to factor or graph? Well, let's see. We would need to see, are there factors of 10 that add to -7? There are, so we could solve this by factoring. And that concludes solving quadratic functions by factoring.